All right, folks, we are back. This is Dr. Jenkins. This is going to be part 2 of our video for this first big chapter. In the first part of the video, we introduced the macro and micronutrients. And for the macronutrients, we talked about their basic structure and function. All right. Well, now we're on to the next part of this chapter, which is an important one. It's basically nutrition guidelines. In other words, how do we know what to eat and how much of everything to eat? Now, you're not going to need to know everything. You're going to see a lot of information. You're not going to need to know everything. You're going to need to know what I circle and talk about. So when you see the word dietary reference intakes, that sounds kind of boring, right? What we're going to start with are a set of guidelines put forth by the U.S. and Canada. So you don't have to memorize dietary reference guidelines. But what we are going to start with is just knowing there's a set of guidelines put forth by the U.S. and Canada. A set of guidelines. They're listed down here. We're going to talk about the recommended dietary allowance, the tolerable upper intake level, and our energy recommendations. What I want to point out is these are a set of guidelines issued by a legitimate source. So these are guidelines that have been put forth from a scientific body. So they're not just hoo-hoo, it's legitimate stuff, okay? They are based on what a healthy person should be eating. So if someone is ill or has a certain situation, these are not for them. These are just basic guidelines for a healthy individual. They are updated every 5 years. And I want to say maybe, because, it's obviously past that, maybe the latest one is 2021. I don't care about the necessary date, but I'm just saying that they're updated. So I know this sounds boring, but these are legitimate guidelines updated by a scientific body. If I go back for a second, you don't need to know this one, but I think it's interesting. Policymakers here in the U.S. government in particular use these when they're making guidelines for programs such as WIC. So, side note, but it's interesting. Okay. When I just recently updated this, and I went back in time because I was wondering, where did these come from? You don't need to know this slide. I just think it's interesting. These guidelines first came about during World War II when the government realized that they needed to take care of their soldiers and that realized that they were not getting what they needed. So that's kind of interesting. And then I went down another rabbit hole and I wanted to see what they were eating. They didn't have the MREs now that are freeze-dried, and I'm sure it's not, it's not great, but compared to this, look at this, the sea rations, the sea rats, they called them. How would you like to eat that? Although if you're really hungry, I would eat that if I had to. And then apparently they had, for shorter duration missions, something a little bit fancier, the K rations. Notice it includes the cigarettes, of course. At least we've advanced in that. Okay, you're not going to need to know everything. We're just going to cover the basics. So the first thing that they did is they put something together called the Estimated Average Requirement, EAR. This was basically how much of each nutrient or each food item. When they first put these together, they wanted it to fit as many people as possible. And this first set of guidelines was good enough to satisfy healthy individuals. But this wasn't good enough. And you can see these became the starting point for the others. You don't need to know this. I know it's in red. You don't need to know it. Okay? This was a starting point. We're not going to worry about the graph. It's a starting point. What came next is what I would like you to know. What came next were the RDAs, Recommended Dietary Allowance. You may have heard of the RDAs. These were taken from the initial values, but purposely set higher. So remember I said the initial EAR values were probably good enough to meet 50% of the needs of people? That wasn't good enough. So they purposely took those and set them higher so that they would meet the needs of most people. And this is what I'd like you to know. The RDAs. This is going to be our recommended amount of each food that's needed. How much? It was purposely set higher than the initial guidelines, and because of that, it meets the needs of almost all healthy people. It's okay to set things a little bit higher. Who cares if we get a little bit more calcium than we think? Because the bigger risk is having it be too low, right? We understand that people are not going to need everything every day, but by purposely setting them a little bit higher, we're going to be sure that people are hopefully getting what they need. So RDAs, a recommendation on how much of each food is needed, purposely set higher so that it'll meet the needs of almost everybody. Don't worry about the graphs. So what you need to know so far are the RDAs. They took the original EAR guidelines, purposely set them higher so that it'll meet the needs of almost everyone. How much of each food item is needed. You don't need to know any of the specifics. I wanted to just show you some of them. I took this from the National Institute of Health website. Excuse me, I just had a little sip here. And the RDAs are the ones that are not starred. So what did I... Calcium. Let's look at calcium, because that was my example. They even do it by gender and age. So for the RDAs, let's say this is me, I'm in this category. So the RDA, or the recommended amount of calcium I need per day, is 1,000 milligrams. So it gives it for vitamins and minerals, a whole bunch of other stuff too. You don't need to know the specifics, I'm just showing you an example. Okay, there's another thing here, but you don't need to know. You don't need to know this, it's just extra. Sometimes there isn't enough scientific evidence to create a recommended dietary allowance. In that case, when there's not enough scientific consensus, they have what they call an adequate intake for lesser known nutrients. It's a goal for how much. You don't need to know these. In this same graph, the ones that are starred are the adequate intakes. These would be for things that we don't have as much information on, like fluoride. But again, you don't need to know that. Don't worry about it. So far, the only thing you had to know was the recommended dietary allowance. How much of each nutrient we need, purposely set higher so it meets the needs of almost everyone. The second one I would like you to know would be the tolerable upper intake level. This is exactly what it sounds like. The highest amount of nutrient that can be consumed without harm. It turns out if we bring in too much, that can be toxic. And in particular, we're talking about vitamins and minerals. In particular, we're talking about vitamins and minerals. The upper limit, the highest amount that can be taken in before it's harmful or toxic. Some people don't realize that this is a possibility. For example, again, I went to the National Institute of Health website, and they had tables for the upper limits as well. Did you know? Let's take vitamin C. Did you know? So I'm, again, here. The tolerable upper intake is 2,000 milligrams per day. What this means is, based on my age and gender, if I bring in more than 2,000 milligrams of vitamin C per day, it could be toxic and have negative effects on my body. Absolutely a true thing. Good. The third thing I'd like you to know, so far, what have we covered for these dietary reference intakes or guidelines? We talked about the RDA. how much of each nutrient you need, purposely set higher to meet the needs of pretty much everybody. Then we talked about the upper limit. The upper limit is how much you can have of something before it becomes toxic to your body. Now, we're going to talk about the AMDRs. I'm going to wait to come back to this one, because what I want to talk about is the AMDRs, acceptable macronutrient distribution ranges. Is there a slide after this? Let's see. It's the same thing. Okay. You've already seen these. We're talking about the AMDRs, acceptable macronutrient distribution ranges. You're not going to have to spell that out, okay? This is the percentage of carbs, fat, and protein you should be bringing in each day. And I'm sorry it's a little bit busy here at the bottom. You already know these because we've talked about them. I'm just telling you what they're officially called, acceptable macronutrient distribution ranges. We already know this, right? Your diet should be somewhere between 45 and 65% carbohydrates. Your calories should be somewhere between 20 and 35% fat, and somewhere between 10 and 35% protein. This I got from the NIH. Look, fat, 20 to 35%. Carbohydrates, 45 to 65%. Protein, 10 to 35%. I'm not making this up, folks. We've already talked about why having them as a range is important. It's important to be as a range because people have different needs of these major macronutrients. A marathon runner needs more carbohydrates, so they might be at the top limit for carbohydrates. A couch potato needs less carbs. And it's even different based on individuals, right? You can have two people that are both marathon runners, but they might have slightly different needs. So this range gives us some room to play with. It could be someone that's a diabetic. It's important for them to have less carbohydrates and less fat. A weightlifter, and that's different from a marathon runner. The marathon runner needed a lot more carbohydrates. The weightlifter, because they're doing such high intensity on their muscles, probably going to need a little bit more protein. You don't need to be able to give these examples now, but I'm just explaining why it's a range. There are more resources for these. You know how things are now. So if you wanted to go on and see some of these guidelines, the RDAs, the upper limit, and the AMDRs, how they would fit you, you can go online. Okay. So do these relate to nutrition labels? Because we're going to talk about that in this chapter also. The thing that we talked about was the RDA, Recommended Dietary Allowance. How much of each nutrient we need. Purposely set higher so it meets the needs of almost everyone. If you look at a nutrition label, and this is the newer setup, what you'll see is they have percent daily value. So the verbiage is different. What on earth is percent daily value? Well, we're not going to get too much in the weeds, but all I want to say to you is the percent daily value is in fact based on the RDAs. So while the nutrition labels, while they use different terminology, they are based off the RDAs. So there is some consistency. It's not the exact same, but it's based on them. If you really want to get in the weeds, they change the terminology a little bit because the RDAs are sometimes in different units. Some of the RDAs for a nutrient will be in milligrams. Sometimes it'll be in grams. Sometimes it'll be in other units. So by using a percent daily value, it's a way to be able to compare without having to use units. That's why they did it. You don't need to know all that. I'm just pointing out the labels, even though it says percent daily value, they are based off of the RDAs. So there is some consistency there, which is actually nice to see, right? So what are the ones that you needed to know? You needed to know the RDA, how much, the amount of each food item, purposely set higher to meet the needs of almost everyone. We talked about the upper intake level, the highest amount of nutrient that can be brought in before it causes harm. I'm going to come back to the estimated energy requirement. You will need to know, but I'm going to come back. And then the last thing so far would be the AMDRs. Those are the percentages of carbs, fat, and protein. So folks, it's not so bad. This is a roadmap. No one's perfect, right? We're not going to meet these needs every day in our diet, but at least it gives us an idea. Good. Remember, these were set for health and may very well need to be adjusted. And no one's going to meet it every day, right? What would matter is over the course of weeks, months, is a person getting close to them. One day it's going to be a little higher in one nutrient, lower in another. That's to be expected. But overall, is someone getting close? That's the goal. Okay. Now let's go to some other sets of nutrition guidelines. Those tables are all good and well, but how do we apply them? So let's talk about MyPlate. We're going to talk mostly about MyPlate. Here are another set of guidelines put forth by the government. These are not about specific nutrient amounts. Those we just covered in the dietary reference intakes. These are meant to be more of an overall guideline. These are again designed for healthy people over the age of 2, technically. There's 2 of them. We're going to focus mostly on MyPlate. Listen, folks, you can read through the dietary guidelines for Americans. These are simple guidelines put forth by the government. Again, instead of being a specific guideline for each nutrient, these are more overall. I mean, check it out. The most recent edition of the Dietary Guidelines for America, eat healthy over every life stage. Customize your choices to include your preferences, cultural traditions, and a budget. You can read through these, folks. I'm sorry at the bottom it's cut off. You don't need to memorize these. I'm just pointing out that there's another set of overall guidelines, but it's pretty much common sense. What I do want to talk about is MyPlate. So you don't need to memorize these dietary guidelines for Americans. They even have a whole thing online. Okay, I want to focus on MyPlate. This is a more visual overall guideline, MyPlate. Now, if you're old like me, we first started with the 4 food groups. Then it became the Food Guide Pyramid. The most recent one, 2011, I think it says. If I go back, let me see. What does it say? Released in 2011 is MyPlate. MyPlate. Okay. So MyPlate is a visual representation. These, of course, are going to follow the RDAs and the AMDRs, but it's a more visual representation. I know that this might sound boring, okay, but, think about traffic and roads. If we don't have road signs, we're not going to know where to go. It's going to be chaos. Without these visual representations, without these guidelines, it would be chaos, folks. Pizza and ice cream every day. That would not be good. Don't do that. Don't do that. So here's what I'd like you to know from MyPlate. This gives us an idea for each meal, what the ideal plate should look like. And, folks, check it out. Half of your plate, according to this, fruits and veggies. The remaining half, a quarter grains and a quarter protein. So you can see this half, fruits and veggies. This half is a quarter grains and a quarter protein. This falls in line with what we talked about in the first video, when we introduced carbohydrates, fat, and protein. When we talked about the percentages that we need of each. Remember we said you don't need as much protein through diet as you might think. If you think about those percentages, what do we need the most of? Carbohydrates, right? So you can see protein here is a quarter of the plate. Think about your plates. Think about if you go out to eat. I'm guessing that it's more than a quarter of your plate that is protein. This falls in line with what we talked about. I'm not saying protein's less important, but remember, our body makes over half of our amino acids for us. Our body makes protein for us. It is not the same. We do not make carbohydrates or fat in the same way. So because our body makes protein for us, we don't need as much of it through our diet. The rest here is all extra. They talk about 1 serving of dairy, add margarine or oil at food prep, blah, 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 blah. But I'd like you to know those first 3 points, okay? My Plate gives a bunch of other recommendations. The last thing I want to point out for My Plate, they have something called discretionary calories. So in this guideline, if half your plate is fruits and veggies and a quarter is grain and a quarter is protein, you're actually going to meet all your nutrient recommendations and still have calories left over. So if you follow the plate as it says, you're going to have some calories left over. And that's what's meant to be used as discretionary. You could have more fruits and veggies, or you could have sensible treats, smiley face. So the way that they do it is, if you follow My Plate regularly, you're going to have some calories left over, and that's what you can use for your discretionary. According to them, it should not exceed 15% of your total calorie intake. I'm not going to ask you that number, but I just put it on there. And, this being the age that we're in, there's a bunch of other tools, so you can actually go online. You can get your specific guidelines. You can put in your age, height, weight, activity level, gender. They have recipes, ideas. So there's even an app for it. Oh my goodness. So they actually have quite a lot of tools, My Plate. There's other ways that we can look at nutritional guidelines. This is from an older textbook, which you can probably tell right away. You don't need to know this. But there's other examples out there of what a healthy plate might look like. All right. If you would like some information on how to make more healthful choices, here you go. I've included some sample foods that would be more healthful. This is all extra, folks. Okay. Now, the last part of this chapter, we have some odds and ends. Serving size, nutrition labels, and calorie recommendations. And then there's one more. Hold on, it's coming to me. Claims on food packaging. But bear with me. All right. Serving sizes. It's important that we have an idea what a serving size is, okay? It's pretty obvious that we probably eat more than 1 serving, and sometimes that's okay. But it's important to have an idea. When we look at these guidelines are based off of 1 serving. Technically, what's 1 serving? I'd like you to know only a couple. Look, 1 serving of meat, chicken, or fish, protein, 3 ounces. That is less than you think. If you want to have an idea what that means, 3 ounces would be the size of a deck of cards, or maybe the palm of your hand. Vegetables, ½ cup. Pasta, ½ cup. Do I have pasta on here? I like you to know pasta. Oh yeah, it does say pasta right there. I know when I have pasta, I definitely have more than a ½ cup. A ½ cup is like two bites. Fruit, medium in size. I gave you an example of dairy, 1 ounce of cheese, which is not very big. So you're going to go over these sometimes, but when we look at labels, when we look at more information here, they're doing it often off of one serving size. These are the ones that I'd like you to know. Again, here are some ideas. What did we say? A serving of protein is about the size of the palm. Vegetables like the fist. It just gives you an idea. Okay. These have changed over time. I mean, back to the old little candy bar, it was small. Now, the candy bar is like double the size. And how can we be blamed for eating the whole thing? I'm just saying, it happens. Think about soda. Not that you should drink that anyway, but, I mean, come on. They get bigger. When you go out to eat, right? Here's what 3 ounces of meat looks like. When you go out to eat, if you go to a steakhouse, for example, what is the smallest size you can get? An 8-ounce filet mignon? 12-ounce ribeye or something? Even an 8-ounce is still over twice one serving. Look at the serving size of pasta. That's like so many. It's okay to have more, but we just have to understand that we're having more, because pretty quickly we can exceed our recommendations. Okay. Now I'm going to go back for a sec, because the one thing we haven't talked about is a recommendation on how many calories you should be taking in. We've talked about I'm going to review again, folks, because the more I review, hopefully the better it sticks in. The RDAs were a recommendation on how much of each nutrient. 1,000 milligrams of calcium, right? The upper limits, how much we can have of something before it's toxic. The AMDRs, what percentages of each carbs, fat, and protein do we need? But what have we not talked about yet? How many calories? How many overall calories? And what we're going to add to that right now is something called the EER. Apparently I can't talk and write at the same time. EER. So folks, I don't think I'm being too bad here. These are the recommendations we need to know. Plus we also talked about my plate. Okay? But let's address how many calories. Now, there is a quick and dirty way. A quick and dirty way is take your body weight in pounds, and there's a typo here, I'm so sorry. So sorry. Take your weight in pounds and multiply it by 10. Let's say I'm around 150. If I take my weight in pounds and I add a 0, multiply by 10, this gives me a general guideline of how many calories I need just to keep up with body functioning. The fancy way of saying that is basal or resting metabolism. So take your weight in pounds, multiply by 10. This gives you a quick and dirty estimate of how many calories you need just at rest. How many calories a person needs roundabout just at rest to keep their body organs going. Now, if you walk around, certainly if you exercise, you're going to need more calories. That number is going to go up. But this just starts the process, gives us a ballpark. The more specific way to do it is what I had said, the EER, estimated energy requirement. What is it? A formula. So the EER is a formula we can use to estimate how many calories a person needs. We're going to be doing this later in the semester. Most of us here are probably 19 or older. I sure am. So if I'm over 19, I'm obviously a woman. This would be the formula I use. The EER equals. And you can see what are the things that it takes into consideration. Age. PA is physical activity. Weight. And height. So the EER is a formula. It's a formula that we can use to estimate how many calories we need per day. This particular formula takes into consideration physical activity. You look at a chart and you pick a physical activity number. You're going to be doing this for yourself later in this course. Now, back in the old days, there used to be charts. We've gone away from this because everyone's different. If you wanted to give an idea, here's an old chart. This is an older one. Okay, what does it say? From 2002. I bet most of you weren't even born then. Oh dear. So we don't like to use charts as much, but they're out there. The best way to do it would be to do an equation. These numbers are still approximations, right? But it gives us a ballpark. Once you have a ballpark, you can start to play around with it. Maybe based on genetics, you have a higher metabolic rate than someone else who is the same age, height, weight. It's possible, right? Okay, but it gives us a ballpark. All right, let's finish this chapter. Here we are talking about food labels. Yes, yes, yes. You need to be able to read the basics of a food label. What do you need to know? You ready? This is a requirement by the FDA for every packaged food. Every packaged food must have a food label. It's been that way for a while, since the 20s. I mean, they've obviously progressed since then. This most recent one was updated in 2016. Okay. So every packaged food label must have one. There are some exemptions. Non-packaged food. One way you can think about this is to think about the layout of a grocery store. The packaged foods that are required to have a food label, the packaged foods tend to be in the aisles, in the center aisles. Cereal, crackers, anything you get, a box of pasta, ketchup, can of beans, spaghetti sauce. Anything you get from the aisles is more of a packaged food, and that is required to have a food label. Some of the non-packaged foods in a grocery store, they tend to be on the perimeter. Think about the produce. That's usually on one side, right? In the back is usually your deli with sliced meats. They're not going to come with a package on them. So there are some exemptions. However, their nutrient information still must be available to you. Sometimes they'll be posted, but also they're required to give them to you if you ask. So if you're in the produce aisle and you say, I really want the nutritional information on this apple, they are required to give it to you. Okay? So what are some of the exemptions? Things that are like the produce, the deli, things like that. Okay. It's not that bad. Come on. So if we go, and I got this stuff straight from the FDA website, right? So each label has to look the same. They put on the serving size. So the information they're going to give you, the number of calories, the grams of nutrients, they're based off of one serving, right? So they're going to tell you what one serving is. For example, this is sample label for frozen lasagna. Serving size is 1 cup. If this came in a box, I'm guessing most of us would probably eat more than just a quarter of it. Because that's what it's saying. The serving size is 1 cup. But how many servings are in that container? 4. So if you ate the whole box, you would need to take these values and multiply them by 4. Total calories per serving. What are the things that we're going to point out? Total grams of fat per serving. Total grams of carbohydrates per serving. Total grams of protein per serving. It does give us that percent daily value. If you recall, the percent daily value is not the same as the RDA, but it's based off of it. According to them, 5% or less is low, 20% or more is high. You don't need to know that for me right now. I would like to point out, though, those percent daily values are based off of a 2,000 calorie diet. What if you don't need as many as 2,000 calories? They would not be accurate for you. What if you need more than 2,000 calories? So these percents, I don't think are as valuable because they're based off of a fixed 2,000 calorie diet, which is not going to be this, it's not going to meet the needs of everybody. Sometimes there'll be a dual column where they will give you the information per serving, but then they'll also give you the information if you eat the whole container, which I think is pretty helpful. This is a pretzel. Okay. Now we're going to go back and we're going to practice that. But before we do that, some other things to point out. This is an old label right here, okay? The new one's a little bit updated, but I just wanted to show you this picture because it has the ingredient list. Before I do that, they are going to give you some of the micronutrients down here. Okay, great. In addition to listing the grams and the total calories, there's going to be an ingredient list. Did you know what is listed first is present in highest amounts? Look at this example, LA Light Bars. You can see why I picked this. I could make fun of it. LA Light Bars. What is there most of? Caramel. What's caramel? Burnt sugar. Look at in the parentheses. Corn syrup, sugar, cream, fructose. That's more sugar. So the first ingredient, which means that there's the most of it, is sugar. So it might surprise you, because what does the outside of the box say? LA Light Bars. You wouldn't necessarily think, if they're marketing it as light, that what does it have the most of? Sugar. As you get towards the bottom, the last item is what is present in lowest amounts. Definitely need to know that, okay? So here are some examples that you can use to practice. I don't know why my numbers didn't come over. This gives you some examples. So this is a new label for Kraft macaroni and cheese. I think we've all seen this, probably had it. So I'm giving you an example. During a study break, because you're going to study so much, let's say you eat a whole box, full box, prepared. So the way this is done is they give you some recommendations here with the dry mix, but I'm asking you for the nutritional information prepared, which means I'm asking this one. What does that say? Per 1 cup prepared. Per 1 cup prepared. So you're going to want to read this side, right? Per 1 cup. A serving size is 1 cup. A serving size is 1 cup. But what if you had the whole box? How many servings per container? 3. So if I'm asking you how many calories, kilocalories, did you ingest in total? How many calories is there per cup? 360. But if I had the whole thing, I had 3 servings. So I would need to take 360 and multiply it by 3. See how we do that? I'm going to let you look over the rest. And then at the end, you can see the answers. I have another example. Here we have, the next morning you pour a bowl of Cheerios. You have 1.5 cups. What is a serving? A cup. So if you have 1.5 cups, you have to take the calories and then add another half serving worth. You used a half cup of skim milk, but that's what it says here too, half cup of skim milk. And again, I don't know why the numbers didn't come through. How many total calories did you ingest? If I have 1.5 cups, well, I had 180 because that's 1 cup, but then I had a half cup. Was 180 divided by 2? 90. So I would take 180 plus 90. That would be how many calories? I'm going to let you look through the rest. At the end, you can practice. A couple more examples here. What if we, and these are old labels, my apologies. What if we compare whole milk to 2% to skim? Practices, you can do this on your own. I really encourage you to do so you can practice at the end. Okay, we're coming down the home stretch here, folks. In addition to having a mandatory format for a nutrition label, there are also rules about what can be written on the packaging, which is great. Folks, these companies, they cannot say reduced fat just because they want to. When a package says reduced fat, they've got to fit some sort of guideline in order to be able to say that. I'm going to give you some examples, but I think it's really important to know that at least we have some guidelines, right? So let's do some examples. First of all, you don't need to memorize all of these. That will be ridiculous. I'm just giving you an example. All you need to know right now is that there are guidelines. In order to say something like these, you have to meet a certain guideline. You don't need to memorize what they are. Let me just give you an example. In order for a company to say reduced fat, that food item must have 25% less fat than the original. Let's look at an example. I've got regular Utz potato chips on the left, reduced fat on the right. Same item, Ripple's potato chips. Regulars on the left, reduced fat on the right. Let's look at per serving, the regular. 10 grams of fat. In order to meet the recommendation for reduced fat, it must have 25% less fat. This has 10 grams of fat. This has 7. So we take 10 minus 7 to get 3 grams. So the reduced fat has 3 grams less fat per serving. Is that 25%? It's 3 grams less divided by 10 times 100, 30%. So does this meet the definition? Yes. That may not be as much reduced fat as you think. 25% isn't that much, right? But technically, they meet the guidelines. Other examples. Again, you don't need to memorize the specific examples. I'm just giving you examples. In order for something to say lean, particularly like a lean meat, it must have less than 10 grams of total fat per serving. So let's see. For something to say lean, it must have less than 10 grams of fat per serving. Here we have, ground beef. Lean, 90% lean. Does it meet the guideline? Look at the serving size, 3 ounces. Got it. How many grams of fat per serving? 9.97. Boy, do they get right up to the edge. They want to keep you buying it and keep the flavor. So, is it under 10 grams of fat per serving? Yes. It actually meets the guidelines, but barely. Okay. Oh yeah, and also you're probably going to have more than 1 serving. So you don't need to know the specifics, just that in order to say reduced fat, lean, etc., they have to meet some kind of guideline. Now, these we are going to have you know. More definitions. Now, for our purposes, we can lump these two together. Processed or refined. Basically, these are both words for processing. Pretty much anything that you get in the center aisles of the grocery store, any of those packaged foods are processed. That's how we can have foods that have such a long shelf life. Otherwise, a loaf of bread would go bad in 2 days. So things are processed and or refined. Again, we're just going to combine these two to mean processed. It lengthens the shelf life. Now, what happens though is in the chemical processing, a lot of times nutrients are removed. Take grains, like a white pasta, white bread. They're processed. They only use a portion of the grain. They don't use the whole grain. And in doing so, some of the nutrients are stripped. So In our country, we need to process so we can keep the food to have a good shelf life, but it does often remove some of the nutrients along the way. Because of that, oftentimes foods are then either enriched or refined. So I'm doing this in order. Many of our packaged foods are processed. They go through some sort of added chemical or some sort of chemical processing to, among other things, increase the shelf life, and nutrients are often lost along the way. Oftentimes, after that, the foods will be enriched. Enriched means to replace nutrients back to the original levels. It's a little bit of a misnomer because enriched means more, but actually it's not more. They're just replacing the nutrients back to the original. However, something can be fortified. Fortified means they add the nutrients back above original levels. So make sure you know the difference between those two. Enriched, they add some of those nutrients back to the original levels that were there before processing. Fortified means they put them back above. So I've given you some examples. We can see white bread versus whole grain. And by the way, if you just buy wheat, that doesn't necessarily mean that there's no processing. You would rather see whole grain because whole grain is where the whole grain was used. And that means that more nutrients are kept. So if we compare these two, a lot of the basic things are the same, but the whole grain, in particular, we're talking about vitamins and minerals. The whole grain has more vitamins and minerals that have been kept because the whole grain was used. Here we only have 4. Here we list 2, 4, 6, 8, twice as much. Okay. I talked about fortified. Fortified means, let's go back, fortified means that they replace things above the original levels. Did you know, a lot of times we purposely fortify. For example, look at milk. The next time you're in the grocery store, you'll often see fortified with vitamins A and D. Vitamin A and D. Did you know the biggest source for vitamin D in our country is that it's been purposely added to milk? Because we know that we're not as likely to get it through the natural means, leafy green vegetables. I mean, I do. I just had some leafy greens today. Arugula, it was delicious. So a lot of times, not only do we add things just to replace them, but we add them knowing that we're not likely to get them through other means. Okay, we are coming down towards the end here. And these things I would like you to know. There are 3 main types of labeling claims. This is different from reduced fat or lean. These are labeling claims that can tell us, can lower cholesterol, supports bone health. So this is a different set of claims. Many of these, I should say. So the 3 types are nutrient content. These two go together because these are health claims. Let me choose a different color. Maybe, purple. No, it's too close. How about orange? Structure function claims. So we've got 3 types of separate labeling claims. Nutrient content, health, structure function. Some of these we have discussed. Let's talk about these. Nutrient content. This is what we've already discussed. So I was a little bit wrong if I go back for a moment. The nutrient content we have discussed. This is what it says it is. Reduced fat, lean. These are claims on the label about its nutrient content. Is it low sodium, reduced fat? We already know that these must meet criteria. So the claims that we've already introduced are called nutrient content. Look, high fiber, extra lean, high protein. These are claims about the nutrient content of the food. We already know they must meet some sort of guideline. Let's go to the second type of claim, which is a health claim. A health claim, there's two types. There's health claims that meet a scientific agreement, and these were just updated. In other words, these are quote-unquote authorized. And then there's also health claims that are qualified. So we've got qualified health claims versus authorized. Two types of health claims: authorized, qualified. Which is better? Authorized. And that's this one. An authorized health claim meets significant scientific agreement. In other words, look, can help lower cholesterol. Isn't that a health claim? By eating this food, it's going to do something to your health. Lower cholesterol. Right? Now, they cannot say that it causes or will get rid of something. They can't say, eat Honey Nut Cheerios and you'll never have a heart attack because of cholesterol. It may say, may reduce, that should be may, my bad. It should say, it may, they have to be very careful about what they say, may reduce the risk, right? My point is the authorized health claim meets a rigorous standard. In other words, there is many journals, scientific articles that back this up. Having something like this in your diet has been shown to lower cholesterol. Has been reviewed by the FDA. There's significant scientific agreement. So again, we're talking about health claims. The authorized health claim is one that meets significant scientific research. There's also a qualified health claim. This is supported by some, but does not meet a significant. Because of that, and this is what's new, folks, it used to be only one type of health claim, and it wasn't separated by how much scientific agreement there is. So now we've separated this, so you know if it's this, authorized, there's significant scientific agreement. If you see a disclaimer, look at this one, heart healthy nuts. Heart healthy. There's going to be, it even says qualified health claim, qualified. There's some evidence, but it's not significant. So it doesn't meet as rigorous a standard. Good. So we have our nutrient content claims that talks about reduced fat, lean, must meet some sort of standard. There are health claims. A health claim is a claim that eating this food can do something to your health. There's a I keep forgetting the word, authorized. There's an authorized one that has more scientific agreement, and there's a qualified one that has less. The last thing is a structure function claim. A structure function claim describes how a nutrient can affect your body. This is kind of the middle ground. And I point this out because unlike the health claims, no FDA approval, there are no guidelines. So this is kind of the middle ground. It doesn't talk about a health condition. It doesn't say heart healthy, can reduce cholesterol. It basically says this can influence your body. Look, help support a healthy immune system. It's kind of this vague middle ground. And I'm pointing this out because this structure function claim does not need to be FDA approved. So when you read this, it can help support a healthy immune system. We're not guaranteed that it's actually true. Okay, good. I'm going to skip that. These are the answers to the nutrition label questions we had at the beginning. So feel free to check yourself, right? This is good practice for you. Here's our example of the Honey Nut Cheerios. You have access to this. I'm not going to go through it with you, but it's good practice. There you go, folks. As always, I'm here if you have questions. Study hard. Good job.